Okay, it's Professor Thompson again, and I want to do some derivatives, term 3.5, and I'll start with 21 here. So I just want to find the derivative, and specifically in this section, they ask you to simplify wherever possible. So in general, I don't care about simplification, but in this section, the directions ask you to simplify. So this is g of x equals square root of 1 minus x squared times arc cosine x. So this is very clearly a product rule. This is my A, this is my B. So I want A prime, and I use the power rule on the square root, times the chain rule, which would be minus 2x, and I leave arc cosine x. So that's A prime B, plus AB prime. So I would leave the square roots, but then what is the derivative of our cosine? And that is exactly what I have. It's 1 over square root of 1 minus x squared, but with a big negative out front. So that actually works out that that term will simplify. So g prime of x here, I can simplify first the half and the 2 can cancel over here, and then those will cancel in the second term. So I've got minus x over square root of 1 minus x squared times arc cosine x minus 1. So there's not really any more simplification to do here in this problem. So that answer is fine. Right there. Okay, the next problem to do is 28. And this is y equals arctangent of square root of 1 minus x over 1 plus x. So, arctangent, you should take 1 over 1 plus whatever was inside to the power of 2. And then now I need to multiply by the derivative of what was inside. But just to be a bit more clear, the square root should go all the way down here. And the derivative of what's inside is going to require the chain rule and the quotient rule. So I use the root, the power rule, and then I multiply by the derivative of what's inside using the quotient rule. So it's low d high, which is minus 1, minus high d low, but the derivative of the low is just 1, all over low squared. So that's quite a bit going on, and this is going to take some work to simplify. So we'll have to write that on the next slide, but the first thing is that this first term here, or this first factor, excuse me, the square root squared cancels, so we should start with that. So let's go ahead and write that, start with that on the next slide, and we'll kind of flip back and forth. So this should be 1 over 1 plus 1 minus x over 1 plus x. So that's our first factor. Our second factor, I guess, is a square root on the bottom. So we've got the 1/2 and then 1 over the square root of 1 minus x over 1 plus x. And our third factor, well, let's look at that numerator. That's, so I'm talking about right here. That's minus 1 minus x minus 1 plus x. So those x's will cancel. And that's just minus 2 for that numerator. So that means that I have, for my third factor, I have minus 2 over 1 plus x quantity squared. Okay, well, let's keep simplifying, so let's just look at each factor separately. The first factor, I would like to get rid of this complex fraction. So first, let's do a common denominator on the denominator. So that would be 1 plus x plus 1 minus x all over 1 plus x. And then let's try to make this one more clear as 2. This is square root of 1 minus x divided by 2 square root of 1 plus x. So I can separate that square root. And then the last term I'll leave for now. Now, notice on the first factor, the x's will cancel. And I can go ahead and flip that double fraction. So this is 1 plus x divided by 2. And I can flip this second double fraction as well. So this is 2 times the square root of 1 plus x over the square root of 1 minus x. And then my last term is minus 2 over 1 plus x quantity squared. So I'm getting a bit closer to simplifying here. So my 1 plus x in the first term can cancel with one of these. And certainly all the 2's I have, I can cancel these 2, for example. And now the square root of 1 plus x, I can cancel sort of with half of this one. So I can change this one on the bottom to the square root of 1 plus x. And so what I've got in the denominator now are these 2 square roots that I can put together. So let's go ahead and write on a new slide what I've got left. In my numerator, I've just got minus 2. My denominator, I've got the square root of 1 minus x times 1 plus x, and I can put that all in one square root. And so that's pretty simple. Just to keep it clean, maybe you would write 1 minus x squared as the denominator, all over minus 2. So that's really not too bad, even though that took a lot of work to get to there. That's a pretty nice, clean-looking derivative, which is, for example, something you'd want to do if you were going to take a second derivative. You'd want to do all that work before you took the next derivative. So that finishes this problem 28. And now I will do one more here, number 27. And so this one, you want to find y prime, and this is x inverse sine of x plus the square root of 1 minus x squared. And again, I want to simplify. So first, let's use the product rule here. This is a and this is b. So a prime b, well, a prime is 1, and b is inverse sine. And now I have ab prime, and a is x, b prime is 1 over the square root of 1 minus x squared. And then the last term requires power rule followed by the table. So now let's try to simplify this. Well, my first term is just inverse sine. My second term is x over the square root of 1 minus x squared. My last term, the 1/2 and the 2 can cancel. And I can just say minus 2 over the square root of 1 minus x squared. And so the only real simplification to do this time is to combine my second and my third terms. So this is x minus 2 over the square root of 1 minus x squared. And that is your derivative.